What is CVD? CVD is a process where gaseous precursors react to form a solid coating on a heated substrate. Let's look at a typical example using a very simple schematic to explain the basic principles involved. The vessel in which the process takes place is called the reaction chamber. In this instance, we'll be coating a flat component with a metal coating, reducing the metal chloride with hydrogen. The first action is to heat the component to the desired reaction temperature, which can be anywhere between 200 degrees C and 2200 degrees C, depending on the coating and the component. Once the component reaches the desired temperature, we introduce a controlled flow of mixed reactant gases into the reaction chamber. In this example, we will show a metal being deposited from a metal chloride gas. The first gas is the metal chloride. The metal is shown as blue atoms and the chlorine as green atoms. The metal is combined with chlorine to give a compound that can be maintained as a gas. At the same time, we also introduce a controlled flow of hydrogen gas, shown as red atoms. We adjust the process conditions so that the mixture does not react until it comes into contact with a solid surface, such as the component. As some of the gas molecules come into contact with the substrate, they are adsorbed onto the component surface. They are held onto the surface through relatively weak localized attraction. This adsorption allows the two reactant gas molecules to react together. The chlorine and the hydrogen react together, creating hydrogen chloride waste gas, and the metal atoms remain bonded to the component. The waste gas is continuously removed from the chamber, normally using a vacuum pump, creating a constant flow of reactant gases into the reaction chamber and waste gases out of the reaction chamber. As the coating process initiates, the first deposits are localized. Over time, the whole surface of the substrate becomes covered. The coating will apply to all accessible surfaces, not just the top. For some coatings, and depending on the desired thickness, we can keep this process going to allow the coating to grow. For some thick coatings, we can even remove the substrate, leaving behind the coating as a freestanding component. In the photograph, we can see examples of freestanding components. These samples are made from tungsten. The second photograph shows boron nitride ceramic crucibles.